Hello. So let's just do a simple problem about the electric force between two particles. So you've got this equation. Electric force is a certain constant times Q1, Q2 over the distance between them squared. The force is a vector, but this gives us the magnitude of force. So actually you want to put absolute value bars on those guys, and you can figure out the direction from a free body diagram or something like that. So this gives us the magnitude. You may actually have it this way. Same thing. That 4 pi epsilon naught on the bottom is kind of a mouthful, so some people opt to change it into a k on top. It doesn't really matter, but I'm going to go with the k equation generally because it's quicker. Okay, so I don't know. Let's say we've got out in space somewhere a couple of charges, Q1 and Q2, and let's say they're connected, their centers are connected by a 1 meter rope. Let's see, L, I guess. And I want to find the tension in that rope. So let's say we know these charges, I don't know, 10 coulombs, 20 coulombs. Those are kind of big numbers, but whatever, we're out in space, anything goes, I guess. So my question is, let's find the tension in the rope. All right. So this may be a new force to you, but it's just a force. So pretty much if you're dealing with a problem about forces, asking for forces, simple things like that, it's still going to be free body diagram and Newton's second law. So let's just pick one of these. In some cases, we might need to do a free body diagram of both. Let's see if we can get away with just one of them. So say Q1 over here. Remember, we want our axis. Choose your axis and put it on there, and then put in the forces. So they are both positive 20, or this one's positive 20 and this one's positive 10, because I didn't put a negative sign on there, right? Clearly they're both positive charges, so they're going to repel each other, right? Like charges repel and opposite charges attract. So the electric force on this 20 guy, Q1, oh, should have had that be the 10, whatever. The electric force is going to point this way. Going to want to go away from that other similar charge. But the thing that's going to stop that is the rope. So we're going to have tension in the rope pointing back this way. Alright, and since this is not going anywhere, right, these two charges are not going to get further apart or closer together, well, the sum of the forces is 0, right? The sum of the forces in the x direction, well, equals mass times acceleration. That's Newton's second law. But because they can't go anywhere, they're attached to each other, the sum of the forces is equal to 0. The acceleration is 0. So just continuing the problem from here, the 0 equals, well, looking at my coordinate choice, t is in the positive direction, minus the electric force, which is in the negative direction. And so from that, I get T equals the electric force. Okay, so we started out looking for the tension, but it's actually equal to the electric force in this problem. So T equals K Q1 Q2 over the distance between them squared, and that's that length. All right, the length of the rope is the same as the distance between them. So that is the tension in the rope. And you could plug in the numbers, but I don't want to because K is like got decimals and stuff. Oof, decimals. All right, that's it.